All right. Hey, let me label my graph real quick. Well, actually, let's read through the directions. It says, the figure below shows the velocity of a particle moving along a horizontal s-axis. Hey, yo, key thing here, man, you got to pay attention to is, and when you look at this, you got to look at it as a horizontal axis. I know you see this graph, all right, and to you it's slanted. It's like this, all right, but you're gonna read it as a horizontal from 0 to 5, and I'm gonna explain what all this means in a second. All right. Let me type. Well, let me get some colors. All right, I'm gonna make this yellow. Make that point yellow, and make that point yellow. And then I'm gonna make this green and this green. All right. So yellow, green, yellow, green, yellow. All right. Let's type. That's too big. All right. We're gonna start with at t equals 0. So this right here is t equals 0. All right. So at t equals 0, guys, this y value right here is -8. Oh, wrong color. This is -8 right here. So at t equals 0, the particle is moving at -8 units per second left. All right, and let me explain why I said left. When you look at this, right, y'all see how the y value is below the x-axis? If the y value is below the x-axis, that's a left movement. All right? If it's above the x-axis, then obviously it is a right movement. Y'all follow? Below the x-axis, left movement. Above the x-axis, y movement. Because you still got to look at this as a plane. Like if you saw this as a number line, then this would be to the left. You see what I'm saying? And it's below the x-axis. All right, you have to spin your head. You know what I mean? You see the number line I'm talking about. All right. For this, and I'm going to define this line, I'm going to say from 0 to at 0 less than t less than 1.5. All right. 1.25, excuse me. The velocity / speed is decreasing. All right, let me explain what I mean by this. From 0 to 2.5 in terms of x. So from here, from 0 to 2.5 right there, or that yellow dot. Y'all see it? That's from 0 to 2.5. All right, which refers to this green line right here. All right, what we're saying is the velocity and speed is decreasing. What I mean by decreasing is, what is this line approaching? 0. Y'all see the y is 0? So that means the speed or velocity, there is none. You see what I'm saying? It's slowing down as it approaches 0. Y'all follow me? Yes, no, yes, no. All right, hope y'all paying attention now. Now, right here at 1.25, all right, y'all see that's on the x-axis? That means the speed is what? At x equals 1.25. If the speed is 0, what happens? What did the particle do? It stopped. It's not moving. And anytime y'all got questions, man, say something, all right? Don't sit here and be just winging it. Like, you know what I'm saying? Oh, don't worry. Hey, I'm going to upload a video for you, big dog. So you have it on YouTube, on E-Class. I got you, homie. Coach Moore loves the kids, man. All right. Do I need to review any of this so far? Yeah. The middle one right here. So from 0, you understand this is 0 right here, to x is 1.5, 1.25, right? So we're talking about this right here, this line. All right, see how this line is approaching x is 0 in terms of y, right? Because, quick sidebar. You know how f of x equals y? Well, for the x values in between here, what is it approaching? What's the y value going to be? No, the y value. 0, right? This is the 0 axis, right? -5, 0, 5, right? So this is approaching the 0, the x-axis. Well, approaching 0, the speed or velocity is slowing down. You see what I'm saying? Because again, I'm not reading this like I normally read a graph from left to right. I'm reading this as a flat surface, like a number line almost. So I'm reading from left to right. You know what I'm saying? In the sense that if it's below the x-axis, these are negatives. All right. But as I approach 0, right, the y value as I approach 0 is slowing down because it's about to be 0. That clear it up? Or we got some practice opportunities coming up. All right. This next green part, we need to define it. So at 1.25, which is less than t, which is less than, oh, these should be t's. I don't know why I put x right there, sorry. But t, because it's in terms of time, the time is less than 5. Less than 5. What can we say right here? Just looking at what we did right here, what can we say about this now? It's increasing, right? And why is it increasing? What are the y values doing? The y values are getting larger, so it's increasing. Now, am I going left or right? Right. Why am I going right again? It's above the x-axis. It's above the x-axis, so that's to the right. Say what? No? I'm sorry. So, yes, if this was going that way, you're saying if it was going this way? Yeah. So if it was moving this way, right, I would say that it's also increasing because it's going to the right. Or, yes, it's increasing left. You're right. Is that what you just said? Yeah. It's increasing left. Yeah, you're right. You're right. Increasing left. Because the y value, the x values are getting bigger, right? Okay. All right, last part. And then that last yellow mark at 5. At t equals 5. All right, what can we say at t equals 5? That yellow mark up there. The particle is moving how fast? Moving 25 units per second. And which way is it moving? Right. 25 units. Right. There we go. So right here, you don't have to specify the direction. My fault. In the actual movement. All right. You just specify the direction right here at the actual positions. That's a position. That's a position. That's a position. This is velocity. This is velocity. So let me write that. The velocity is increasing. Okay. Questions? So now, by the way, these next problems, we're going to use this equation, guys, right here. x squared minus 8 over x plus 1 squared, okay? So right here, suppose the initial position of a particle in example one, which is what we just used, is s of 0 equals 9. What is the particle's position? All right, so first off, I want y'all to understand this question is asking you about the position. All right, it says initial position. It's asking you about the position, which means we're assuming a position. We're assuming a starting place, okay? Basically, you have an integral. All right, you're going to take that function, you're going to integrate it. All right, your beginning value goes here, your ending value goes here. This is your derivative of dx. So part A right here where it says evaluate t for 1 second. All right, well, we're going to start at 0. We're going to end at 1. All right, and here's the equation. Here's the x squared minus 8 over x plus 1 squared dx. And we're going to go plus 9. And the reason we're doing plus 9 is because we're changing the starting position. You understand? We're supposing or assuming that here's the starting position. You know what I mean? So we add 9 to that. So we're going to integrate this, then add 9 to that. All right? So how do you put that in your calculator? Well, here's how you do it. And again, this is for integrating the velocity to find the distance. You're going to press math. And then once you hit math, go to FNINT. All right, for function integration. All right, and then I put 2 ways right here because this it may look like this if you have an older model calculator. And you go FN parenthesis x squared minus 8 divided by x plus 1 squared, close that parenthesis, and then you'll go comma x because that's for dx, and then comma 0 is where we start, right, and then 1 is where we finish. All right. Now, some of yours is upgraded. So when you do that, it's going to show you the integration. All right. Well, here's where you start, which we start at 0. Here's where you end at 1. And then you put the formula in, x squared minus, or the function, x squared minus 8 divided by x plus 1 squared. And then d, and we're going to evaluate the variables x. We're taking the derivative, we're integrating with respect to x. All right. So take a second, punch that in. Let me know if you have any questions, and then we're looking for an answer. All right, and you should get 5.3. So do that and see if you get 5.3, and if not, ask questions so we can figure out what we're wrong. Where did the x squared come from? From right here. Look, t squared. So x squared, and this would be an x. Ma'am, right here, x. Right, it's dx. So we're doing it with respect to x. All right. I got you here. Give me 1 second. Oh, 5.3. I got you. Here we go, man. Oops, let me do that. All right. So math. Go down to right here, option 9. Does yours look like this? So, oops. Zero to 1. Then we got to do is x squared minus 8 divided by, did you put parentheses around your denominator? X plus 1 squared, right? Then with respect to x, and then we're going to add 9 to that. There's your 5.3. I don't know. Try it again. If you don't get it, then let me look at it. Yo, you need a calculator, my guy? You want to practice? Oh, okay. Yeah. And if you got that one, then go ahead and do the next one. What's up? It's not coming up? All right, let me see. Hold on. Let me stop this. All right. 9. So the next one was 0 to 5. Oops. X squared minus 8 divided by 1 plus x. Oh, it's x plus 1, right? It'd be the same thing. Squared. Comma. Oh, well, this one doesn't need the comma, so I'm straight. X plus 9. All right, 44. Cool beans? All right, so we got 5.3 right here. Excuse me. This one was 44, right? So 5.3 units and 44 units. All right. But the thing is, make sure you understand the questioning right here. This right here is a position question, right? This is not a velocity question. The other type of question you're going to have is velocity. This is a position question. You got it? And we are assuming that we're starting some other place. You see what I'm saying? All right. That's why we added 9 to this. All right, now let's go to 3. 3 says we know now that the particle in example 1 was at s of 0 equals 9 at the beginning of the motion and at s of 5 at 44 at the end. By examining the graph at the position function, though, you can see that the particle did not travel from 9 to 44, all right? So it didn't travel from 9 to 44 directly. It began its trip by moving to the left. All right, so what we got to do here is find a displacement of the particle. So displacement means, again, in number 1, we assume that it started at 9, right? Well, we're not assuming it anymore. So now when we do it, we don't need to add 9 anymore. You understand? All right. So y'all work that out real quick. Let me type for a second. All right. And the displacement is a change from starting point to end point, and we changed it, right? We're not at 9 anymore. We're going to start at 0. All right, to 5. That's why we don't have to add 9. So when y'all do this, what'd you get? Huh? 35 units? 35 units, all right? It's also just good practice for you to punch it in and make sure you know how to do this. Because that skill is what you need to know as well on the test. That's on you. So on the test, you're like, how you punch that in again? I'm going to say, I don't know. You got to know it. All right. And number 4. Number 4 says find the total travel. Oh, my fault. So again, let's just talk about this. When you talk about displacement, understand you don't need the assumption anymore. All right. You just do it straight up from the start to the ending point. All right. So it was from 0 to 5. Now right here it says find the total distance. Whenever you find the total distance, guys, you got to use the absolute value. All right, absolute value. All right. And how it looks is ABS n squared minus 8 over x plus 1 squared dx. All right. So how do you get the ABS? You're going to press math, and then you're going to go right to NUM, and then you're going to press ABS. All right. So when you do this, you do the function integral button, and then you do the ABS button. All right, and that'll get you to that right there. Matter of fact, here, let me just punch it in real quick so y'all can see it. So math, we need that from 0 to 5. Math, right to number, ABS, and then put it in the equation. DX. So you should look something like that. Immediately, I did the F of N. Is yours coming up like this?
No, like the ABS came up for like the top number.
No. So I'm saying, do you have the integration bar right here on your calculator?
Yes.
All right. So look here. Look, listen. Not a second. I'm sorry. Keep pressing that. So you're going to press math, do the integration, right? From 0 to 5. You got that? Now go ahead, go right here. Now you're gonna press math, go right to NUM numbers, and then ABS. Got it? And now put the rest in, the function in, and you should get 42.6. I'm around at 42.6. If you're having difficulties, let me know. We ended up with 42.6 units, right? Again, total distance, guys. You got to use absolute value. You got it? Now one quick sidebar here. Total distance is the sum, goodness gracious, of all distances. Value. There we go. All right, so you need all the distances. You need absolute value, so all the distances are positive. All right. All right, let's go ahead and start your homework, guys. I'm going to do one problem with y'all. I'm going to do the first one with y'all, and then y'all going to do the second one, all right, and turn it in on a separate sheet of paper. All right. On the back, number one. Number one says you have this equation right here. V of t equals 49 minus 9.8t. All right, between 0, t, and 10. All right, so first what you need to do is graph this. All right, so go ahead and graph this function right here in your calculator. So y equals 49 minus 9.8x, right? Like that, 49 minus 9.8x. We're going to graph it first. Then, of course, hit graph. Now, I've changed my scale a little bit, all right, because I know I'm looking between 0 and 10, right? That's what they told us, between 0 and 10. I just changed that. And then I used my y-intercept, which is 49, so I went up to 49 and minimum 49, all right? I just wanted a better picture. You can do whatever, you know what I'm saying? As long as you understand your y-intercept, that constant, that's your y-intercept, all right? So I want you to be able to see the whole graph, so that way when we mark it up, like we did with problem number 1, you'll be able to do that. So A, you want to graph it. All right, so this is 49. All right, and then what was that y-intercept? 5, right? That was 5? All right, cool. And then way out here is 10. All right, cool. So let's start right here. at t equals 0. T equals 0. What do we say about t equals 0? What do we say this? Look at number 1. How do we talk about this? All right, the particle is what? The particle is moving how? Or how fast? At 49 units, right? Units per second. All right, at t equals 0, the particle is moving 49 units per second. Which way? To the right. Why to the right? It's above the x-axis. It moves to the right because it's above the x-axis. All right, so now let's talk about from between 0 and 5. Between 0 and 5, what are we saying? Is the graph increasing or, is it getting faster or slower? And look at what is approaching. What is it approaching? 0. So is it getting faster or slower? It's getting slower, or right? It's slowing down. It's slowing down because it's approaching 0. You got a question? No. Oh, I thought it was a question. Oh, throwing what up? All right. It's slowing down, right? The particle is slowing down. All right, what about at t equals 5? The particle stop because it's at 0, right? The speed is 0 right here, 0 units. So it's 0. Any questions so far? All right, and then right here from five less than t less than 10. What do we say about the particle here? What's the particle doing? Is it going to 1 or away from 1? Away from 1. So we say the particle's what? Increasing. All right, we say increasing here. I'm just gonna keep it simple. We'll say getting faster or speeding up. It says particle. Sorry, my handwriting is bad. The particle's getting faster, right? Because it's moving away from 0. All right, now is it moving left or right? Which way? Left. How do we know left? It's below the x-axis. Below the x-axis is moving left. Above the x-axis is moving right. So this is what you said earlier. You said it's going this way, getting faster, moving left. All right. Questions over this first part? Part B, what does part B ask us? Find a particle's displacement for the given time interval. So it says find a displacement. What does that mean? We got to integrate from what? 0 to 10, right?
Wait.
9.8x. Yes, ma'am.
Okay, before the last one, it says at 0.5 t said.
All right. Where? So dx, right? 0 to 10, 4.9, 49 minus 9.8x dx. Now, do we need to, did we have an initial value? Right here it says displacement. So the initial value is where we start at, 0, right? So we just differentiate that. So how many units right here would y'all get? Huh? 0 units. Good. Now part C says find the total distance traveled by the particle. So the total distance traveled by the particle. What does that mean? Huh? Yeah, what does that mean specifically for the command we need? We need the absolute value. Right? So punch that in and tell me what you get. Yup. Yeah. So for yours, hold up. For yours, you put the integration, right? Or you go FNINT, right? Of ABS 49 minus 9.8, right? Comma, or 9.x, comma, x, comma, 0, comma, 10. Right? Actually, I don't even think you need this parenthesis right here. No, I don't even think you need that one. I think 9.8x. I think it's that. Try that and let me know. What'd you get now? That's what I got. 245 units. All right, so listen, y'all try number 2. All right, and then bring that on another sheet of paper. Bring me number 2 tomorrow. All right.